We're going to continue looking at how to add and subtract rational expressions in this video. We have three examples we're going to cover. The first one, we have r over r squared minus 16 minus 5 over r plus 4. The first thing you want to do is make sure your denominators are completely factored. That's going to assist us with finding the common denominator. And so this r squared minus 16 is really r plus 4, r minus 4. And so I'm going to rewrite it. So I have r plus 4 times r minus 4. This minus 5 over r plus 4, I don't need to do anything to it. It's completely simplified. And now I look for what my common denominator is going to be. So look at what do they share? They share this r plus 4. They have that in common. So I know that's going to be part of it. Well, what's missing? Well, if they share the r plus 4, this one's missing the r minus 4. And so that is what is part of my common denominator. So my common denominator is r plus 4 and r minus 4. Well, if I look at the first fraction, it's perfect as is. I don't need to multiply anything to the top and the bottom because my denominator already is r plus 4, r minus 4. However, in the second fraction, I am missing an r minus 4 in the bottom. So I'm going to multiply both the top and the bottom by that factor, r minus 4, by the factor that is missing. So here is the process with subtraction that is a little bit difficult. When you are dealing with simplifying from this point, this r is just going to stay as is. I'm going to rewrite this so it's one fraction to make it easier to see the process. Really, since they both have the same denominator, I have r minus 5 times r minus 4 in the top. In the bottom, I have r plus 4 and r minus 4. The reason why I rewrote it as one fraction now is because I need you to see that this minus sign affects the entire numerator. This minus sign really would be distributed to both terms. So I get r minus 5r plus 20 over r plus 4, r minus 4. So the key with subtraction is to remember that minus sign is going to affect both terms. And so I like to rewrite it as one fraction together first and then distribute. So now I'm going to combine like terms. R minus 5r is negative 4r. So I have negative 4r plus 20 over r plus 4, r minus 4. And again, that negative 4r plus 20 has a GCF. I'm going to factor out negative 4. That gives me an r minus 5. And then r plus 4, r minus 4. So after you combine like terms, always make sure can it be factored and simplified. And there's my final answer. So the concept in this problem I want to make sure you understand is that when you're dealing with subtraction, rewrite it as one fraction right away so you can see that this minus sign is going to be distributed to both terms. That's the most common mistake made by students dealing with subtraction. Let's look at example 6. I have y minus 3 on the bottom here. I have y squared minus y minus 6 on the bottom here. So what I'm going to do at this step, I'm going to factor the bottom right now. This gives me y minus 3 and y plus 2. That allows me to see what I need for my common denominator. What do they share? They both have a y minus 3. So you're going to have one of those in your common denominator. Well, what's missing? Well, the y plus 2 is here and it's missing over there. So my common denominator is y minus 3 times y plus 2. And so this is what I want in both denominators. So if I rewrite it, I have 3 over y minus 3. Well, what's missing? I have the y minus 3. I need the y plus 2. So y plus 2 goes in the top and y plus 2 goes in the bottom. I am adding by 2y over y minus 3, y plus 2. So this already has everything I need. It has the common denominator, so I'm going to leave it alone. Now, if you want to follow the same process as we did in example 5 and rewrite it together as one fraction at this point, you can. You can rewrite it as 3 parentheses y plus 2 plus 2y over your common denominator of y minus 3, y plus 2. And then distribute to get 3y plus 6 plus 2y on the top. The bottom stays the same as y minus 3 and y plus 2. And then combine your like terms. You get 5y plus 6 over y minus 3, y plus 2. And this cannot be factored or simplified any further, so that's your answer. And so this one was an example of addition. I could have, at this point, just distributed and gotten 3y plus 6 plus 2y, and then wrote my final answer as 5y plus 6. But I wanted to show you that this combining into one fraction that we did over in example 5 also works for addition if you want to use one process the entire time. Let's look at our last example, example 7. I have 1 over 2 times x plus 5 plus 9x over x plus 3, x plus 5. And so again, the first thing you want to identify and write down is what is your common denominator? What am I trying to put in both denominators? Well, what do they share? They have an x plus 5 in common. So I know that's going to make up part of the denominator. Well, what's missing? This one has a 2, this one doesn't. So I'm going to need a 2 as well in my common denominator. This one has an x plus 3, this one doesn't. And so I need my x plus 3 as well. So this is what I want my denominators to look like. So what am I going to need to do? For the first one, I have 1 over 2 times x plus 5. So I have the 2, I have the x plus 5, I'm missing the x plus 3. So that goes in the top, and that goes in the bottom. For the second fraction, I have plus 9x over x plus 3, x plus 5. Well, what's missing? I have the x plus 3, I have the x plus 5, missing just the 2. So then I'm going to multiply the top and the bottom by 2. Now I'm going to distribute right away in the top, just to try and combine some steps. 1 times x plus 3 is just x plus 3. And I'm going to multiply this out. 9x times 2 is 18x. And I'm going to write them in the same fraction because they have a common denominator now. 2 times x plus 5 times x plus 3. And now I combine like terms. X plus 18x is 19x plus 3 over twice x plus 5, x plus 3. And that is my completely simplified rational expression after adding these two together. So again, make sure you identify your common denominator, look at what's missing. You see here, I try to combine some steps, try and consolidate some steps so it doesn't take as much room. As soon as I write down what I'm missing, I can go ahead and multiply, and write them as one fraction, and then combine my like terms.